Okay, so we're going to talk about line equations. And specifically how we can kind of determine what our line equation is given like certain facts. So first off, there's a few different forms we have line equations in. So we have standard form, and this little symbol means defined by. So that's defined as ax plus by is equal to c. And some kind of important things here are, so a, b, and c are all constants. And then kind of a little tricky to remember. So if you ever kind of get something wrong and you really thought the process was right, considering you'll have to check if a is greater than or equal to 0. So positive or 0. And so then we have slope-intercept, which is the most common form that you will see. I think it's what all of these questions have to do with. And that's going to be y equals mx plus b. And then here we have m is our slope, and b is our y-intercept. So in case we don't remember, we can kind of go over here and thought bubble it. So this will be important. Definitions are very important. So we have to know what slope is. And so slope, we can kind of define it two ways. So we have m, which is equal to y2 minus y1 over x2 minus x1. And then this is also equal to our change in y over the change in x. Yeah, and so then if we look at our y-intercept, this is kind of any point where your graph or your line or kind of whatever function you're working with. So it's when, yeah, well, we'll say graph for writing purposes. So when your graph crosses the y-axis. And so let's kind of think about that a little bit. So if I have my axis here, and then we got x and y, any point that I have on x, or I'm sorry, any point I have on the y-axis, it's kind of interesting because we know something about it. So when you're graphing it, usually we start at the origin and then we move x direction first and then we go y. And so if we notice, if I start at the origin, we never move in the x direction if we landed on the y-axis. So that tells us that our x coordinate is always going to be 0. And so our y-intercept then is y when x is equal to 0, which is kind of cool. We can use that later on. And then finally, not super important. Well, sorry, not that it's not important. It's important, but it's not used very often. So it's point slope form. And you can actually get point slope form. You can derive it using slope. And if you're interested in that, we can talk about that. But it's going to be y minus y1 is equal to m times x minus x1. And then here, it's kind of important to remember, m is going to be our slope. Usually in math, I'd say m's usually a slope. Sometimes it's something called a natural number, but most of the time it's that. And then we have x1, y1 is a point on our line. And it could be any point you want. So that's kind of cool. So a lot of our problems or the problems I suppose you're working on are going to be working with this slope-intercept. So we can talk about that a little bit more. And so kind of what is a line equation? Like what is so important about this y equals mx plus b? Actually, I'm gonna write these guys in a different color just because m and b are constants. So I think it might help everything make a little bit more sense in just a minute. So it's important that we have line equations because this kind of equation, this relationship between y and mx plus b, it's gonna hold true. So this is true for absolutely any single point on your line. Which is interesting because you can use this tiny little phrase and you can find an infinite number of points if you wanted to. So that's kind of the power of that. And so we'll talk about it first. X and y, they're going to be variables, and so they stay variables. We don't necessarily solve for them, but you could plug points in if you wanted. So if you knew maybe a point was on the line and you wanted to use that to find some other information, you would put the x value into here and then your y value into there. And so these guys are variables. And then again we have m is our slope and then b is our y-intercept. And so whenever we're trying to write an equation for a line in this form, what we have to do is these guys stay the same, so they're variables, they're just placeholders. But what we have to do is we have to figure out what the slope is, and we have to figure out what the y-intercept is. So let's talk about slope first. Most of the time you can do it in any order, it depends kind of on what your question is. So a lot of the times we'll use kind of one of these two definitions. So they'll either tell us our starting point and our ending point, and we'll use that to find the distance between, or they might just tell you like you moved up 2 and then over to the right 3, and so that would kind of be this form we would use. And so most of the time we'll kind of rewrite this. So we have our change in y, which can also be written like this. This triangle is called delta. Might have seen it in other places. So it's delta y over delta x, which is pretty cool. So yeah, we'll try and find this, and then we can do an example over on the side after we kind of define stuff. And then if we're looking for our y-intercept, there's 2 ways we can go about this. And it kind of depends on what we have. So if we know what the slope is, and we know a point, so if I know slope and a point, then I'm able to fill in for 3 different variables in our line equation, and 1 or 2 variables and 1 coefficient, and so that will help me find this constant value. So kind of, let's see, if I had x1 and y1, and maybe you already found the slope from up here, or maybe it was told to us. But either way, we know what the slope is. Then what we can kind of do is we're gonna do, we'll use this up here. So that means y1 is equal to m, which we know, and then x1 plus b. And so at this point, if they give you what the point is, x1 is just gonna be a number. So you'll just multiply your numbers together and then kind of solve to find what b is. So that's kind of cool. This guy is interesting, but he's only going to be useful if we're given our standard form or given our point slope form. and then we want to find it. So we can kind of talk about it, but we might save that one for later. I think this is going to be our main method. So let's see what happens. So a lot of the times in the problems, at least that were sent, we're given 2 points. So we'll just pick some 2 random points. Maybe we'll do 5, 10, and then maybe 3, 7. Yeah, so we'll see how it goes. And so let's think about it first. I think maybe the most natural thing to do is we can find our slope, just because we already have the point. So let's see, let's kind of fill that in. I'm gonna label them. I think that's helpful, at least for me. And so we'll go y2 minus y1 over x2 minus x1, and that's going to be 7 minus 10 over 3 minus 5, and so that gives us -3 over -2, which is also 3/2. Ooh, sorry, make it a little prettier. Okay, so we just kind of collect this information. We'll hold on to it, work with it a little bit later. And so now, once I have that, we can kind of move on to this step. So I know what my M is, and then I have 2 different points I can use to fill in for X and Y. So it doesn't really matter which one you do. And we can do both just to kind of prove that. We should get the same answer for B. So if we know y is equal to mx plus b, let's maybe use our first point and plug this one in here. So I know 10 for y, m comes from here, 3/2, and then x is going to be 5 plus b. And so now we can solve for it. So I know 10 is going to be 10, and then 3 times 5 gives me 15 over 2. And then we want to kind of isolate our variable that we're looking at. So we'll do variables on one side, numbers on the other. So if I'm adding 15/2, the opposite of that is subtracting. And then that one's a little tricky, so I'm going to make a common denominator. So then we have 2 over 20 or 20 over 2 minus 5 over 2 gives us 5 over 2 is equal to b. So that's pretty cool. So now let's check and see if it's the same for our other point. Because if it is, we can be pretty confident that we didn't make a mistake. So here we go. Let's see. We'll do 7 now for y, because we got it right here. And then our slope stays the same, because the slope's the same no matter what point we're at. And then we know what x is. X is going to be 3 plus b. And so same kind of process. Can multiply this out. So we'll get, I think it's an improper fraction. So now we have 7 equals 9 over 2 plus b. And so again, we want to isolate b, keep him by himself, so that way this number is telling us just about b. There's nothing else going on. So we'll subtract, because it's the opposite of adding. And then let's get common denominators. Gives us 14 over 2. And then we should be pretty happy about what we've done, because we got 5/2 is equal to b. So that's pretty cool. And so now, how do we use this information that we've just gathered? So whenever we have a equation in slope-intercept form, we always have y is kind of our placeholder for all of the y's that are on this line. And then m is a constant. We know what it is, and it's going to also be the same for every point. So we can write it in. It's going to be 3/2. And then x is another placeholder variable for any point in our equation or on our line, and then we've got b. B is our y-intercept. So we got that as 5/2. So yeah, a little funky. Nothing impossible though. So another way we can kind of do this is if we wanted to graph. So I'm gonna erase it and I'll keep this because this is all we need now. That should be able to give us every single point on the line. And so this would be our algebraic solution, but that's not the only way to do it. We can also do a graphical solution. So we'll draw our axes, and you want to try and put some points in, try and make them as evenly spaced as you can. Doesn't have to be an exact science. Although when you have fractions, it does help. Okay, let's do a few more tick marks. Okay, and so now we'll plot our points. So our first one is going to be 5, 10. Let me see if I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, and we'll go up to 10. And then our second point is going to be 3, 7. So 3, and then about right here. And so now we can kind of notice, so how much did we go up? So we went from 7, goes up to 8, 9, 10, so plus 3, and then we had 3 goes 4, 5, plus 2. So we can also use this to get our slope, if we can see that, which is kind of the same process as using this formula. We're just kind of counting the spaces instead of doing our subtraction. So we'll see then that m is our change in the y-axis, so our change is a positive 3. And then the change in the x-axis, x direction, is a positive 2. So we should be pretty happy, because if this equation is y equals mx plus b, then m is, m is 3/2, which is what we got over here. So we're doing pretty good. So how do we get our y-intercept? So I know to get any other points, I mean there's going to be points in the middle of course, but this is kind of a true fact. We can use kind of any method of moving up and down that would be equivalent to that fraction. So yeah, let's see what happens. So this is also the same as moving down 3 and moving left 2, because these are our equivalent fractions. So we can go 1, 2, 3, and so we'll go from 7 down to 4. Sorry. And then, let's see, we're going left 2. So we're going from 3 to 1. And so let's try again. Let's see what we got, because we're almost at the y-axis, but we want to know b, and then b is whenever x is equal to 0, or on our x or y-axis. So let's try it again. Let's go down 3. So 1, 2, 3, and then over 2 to the left, and we end up at -1, -1, which kind of makes sense. Or sorry, -1, 1. Because 4 minus 3, 1, and then 1 minus 2, -1. And so we can see then that we crossed this y-axis somewhere. It looks kind of like it's between 2 and 3. So we can estimate. My line's not perfect. It's probably a little bit skewed. Should have gone maybe like a little bit closer that way. But either way, if you're using actual graph paper, it'll be a bit more accurate. But we can see then that right between there is 2.5, or it's also the same as 5/2. So yeah, you can use graphs to double check your answers. Yeah, let me know if you have any questions, if anything didn't make sense, or if you want to see anything in a different way. I will try my best to figure that out.